Hello, if you can hear me, type 1 in the comment. You're welcome to GPAD Learn Math. If you can hear me, type 1 in the comment. I welcome all of you. Please, let's like the live. That's one thing. Number 2, let's share the live so other people can join us. As you can see, today we'll be talking about direct and transverse common tangent of two circles. If you can hear me, type 1 in the comment. I just want to be sure that you can hear me. If you can hear me, type 1 in the comments. Okay? We're about to get started. Let's wait for other people to come join us. 7 of you, please let's like the live. Let's like the live. Thank you, every one of you, for joining. Let's like the live. Let's like the live. You are all welcome. Yeah, thank you. Yeah, Sinebi Paul, Dash the Blaze. Thank you. Shows that you can hear me. Okay, without wasting time, we're going to get started. All right. In the last lesson, we talked about intersecting chords, and I gave you some ways on how you can get maybe the length of the chord or the length of the tangent when you have two chords intersecting, and those chords are extended. You have a secant if you extend the chord, right? In today's lesson, we're going to be wrapping up this topic, circle theorems, and this is the last aspect we'll be looking at on circle theorems. So we'll be looking at direct and transverse common tangent of two circles. As you can see, we have a common tangent. You know what a tangent is? A tangent is a line that touches the circle at one point. So this tangent, RS, touches this circle at point R and touches this circle at point S. So it's a common tangent because the same tangent is touching both circles. So RS is a common tangent. PQ is also a common tangent. Okay? Now, look at these two words, direct and transverse. What you have for this first one is direct. The top to the top here. Top R, top S. Same tangent. The same thing at the base here of the circle, P and Q. That's why this one is called direct common tangent. But this one, you see that from top to the base of the other circle. So this is what we call transverse. Like you have this is transverse. Transverse common tangent of both circles. So for, this tangent is touching the circle at P and touching this other circle at Q. Okay, if you are getting what we're doing, can you just type 1 in the comment if you understood what I've done so far. So far I've talked about direct common tangent and transverse common tangent. As you can see, top to top, base to base, direct common tangent. Here, top to base here, same, it's a tangent, but it's touching the top to the base of the other circle. All right, so this is transverse common tangent. Most times you'll be asked to, can common tangent also meet both between both circles, not just outside the circles? Can common tangent also meet between both circles, not just outside the circles? I'm trying to understand what you mean. Not just outside. Not just, what do you mean by not just outside? This is actually external. Oh, okay. I think I understand what you mean now. Maybe you have something like, is this what you mean? Maybe something like this. Is this something like this? This is still a common direct tangent. They will meet here. If you extend these two tangents, they will meet at a point external to the both circles. I don't know if that's what you mean. I'm talking about the direct common. Oh, okay. Yes, if you extend the tangent, they will definitely meet at the point external the circles. Okay, so yes, you can extend this and they will meet outside the circle. All right, so that's what you need to know about direct and transverse common tangent. But Now, look at this. I just wrote something down for you. This is transverse, obviously, right? Look at the tangent touching S and it's going down to the other circle. This is transverse. There are different ways you can, most times you'll be asked to find the length of the tangent. Most times you'll be asked to find the length of it. They will give you the two radii of the circle. They will even give you the distance between the two centers of the circle. And you could be asked to find the length of the tangent. There are different ways. We're going to cover all of those ways in this video. So, as you can see, what we have here now, see, we have, this is a right angle triangle. I mean, OSK is a right angle triangle. OSK is a right angle triangle. The same thing as what? KTW. KTW is a right angle triangle. Now, they will not even put this angle 90 here and angle 90 here. You should know that the angle between a radius and a tangent is 90 degrees. Okay? The angle, so I read it in class 10. The angle between a radius and a tangent is 90 degrees. So that's why this triangle OSK is a right angle triangle. Triangle KTW is also a right angle triangle. Yeah, so we have two right angle triangles. I'm trying to explain this relation. See, what we have here is SK over TK. Where is that? SK. This K is the point where the two lines intersect. What are the two lines? One line is a tangent. The other is the distance between the two centers of the circle. So this triangle is a right angle triangle. This one too is a right angle triangle. How did we come about this relationship? Let me tell you how. I don't know if you know similar shapes. For similar shapes, if the angles in the two shapes are equal, then those shapes are said to be similar. And of course, the ratio of their corresponding sides are equal. Let me say that again. The ratio of their corresponding sides are equal. So what we have here is the ratio of their corresponding sides, because this triangle, this right angle triangle, and this right angle triangle, they are equal. They are similar, not equal, they are similar. Why am I saying that they are similar? See, let us look at the first angle. There's a right angle here. Angle OSK is a right angle. The same thing with what? KTW is a right angle. So we have right angle here, right angle here. All right, that's one of the angles. And I don't know whether you know about vertically opposite angles. If you have two lines intersecting like this, the angles facing each other are said to be equal, vertically opposite. So it means that this angle here and this angle, they are equal. Now we have two equal angles in the respective triangle. Hope that makes sense. Yes, thank you. Thank you so much. Yes, bloodline, thank you. Similar shapes have the same angles, not same length. Yes, but left in proportions. Yes, that's the ratio of their corresponding sides. Thank you for following through. So we have two angles now that are equal. Now, obviously, if two angles in a triangle are equal, it means that the third angle will also be equal. Yes, because if we say this is 60, for instance, this angle is 60 and this is 60, then when you add 60 to 90, what are you going to get? 150. So what should be the next angle after, if you subtract 150 from 180? That would be what, 30. So this will be 30. I'm just assuming this will be 30 as well. So we have come to the conclusion that all the angles in these two triangles are equal. So if they're equal, it means that the ratio of their corresponding sides are equal. See, SK from S to K over TK from T to K, that's the ratio of their corresponding side. TK and SK are corresponding sides, all right? Because they're even opposite the angle, 30 degrees, so they are corresponding sides. Then is equal to what? The other corresponding side. OK, and what? WK. OK is the hypotenuse, is the side facing the right angle. The same thing with this one here. WK is also is also what? Is also the longest side, which is the hypotenuse. So then we can also say that OK over what? WK. Let me say that again. SK over TK is equal to what? OK over what? WK. And this must be equal to the third side, the ratio of the third sides. OS is what? Big R, which is the radius of the bigger circle. And then what? What's the next one? WT, which is what small r. That's the ratio of the third side. So this holds true whenever you have a common tangent to both circles and you have another line that connects the centers of those two circles. If they intersect, you will end up having two right angle triangles, and those two right angle triangles are similar, and then the ratio of their corresponding sides are also similar. So I just had to explain this relationship so that you understand everything I am doing in this lesson. So tips for hard work. I'm a hardworking student. I want to be best in my class first. Okay, don't worry if you keep following my lessons. Of course, this is going to be very easy. So I've been able to explain all these now. This is direct common tangent of two circles. This is transverse common circle, and this is the ratio of their corresponding sides. Because when you have a transverse tangent and you have a line joining the centers of those two circles, you will have two similar right angle triangles, and the ratio of the corresponding sides will be equal as you have right here. If you have any question, ask before we move on to the next aspect. Okay, please, let's like the live. We need to move on. I need to take off this, what I have on the board. If you have any question, kindly ask. Have any question, ask. If you have any question, ask. We need to move on. I hope you can hear me. Please, let's like the live. Thank you for those that are liking the live already. Thank you so much. If you have any question, ask. I need to move on. Any question? We have some very interesting questions lined up today. I'm waiting for your questions if you have. Okay, if there's no question, I have to take off this. Please don't forget, this is direct common tangent, and this is what transverse common tangent. And this is the ratio of their corresponding sides when you have transverse common tangent. Okay, so I need to take off the board. So explain BPT. BPT. What do you mean by BPT? We don't have BPT here. Can I understand the meaning of what you just said so that we can move on? Okay. Yeah. So I want to tell you the formula for the length of a common tangent. So like I said, there are different ways you can actually get the length of, I don't want this thing to confuse anybody. So this is like a subtitle. Okay, so the formula for the length of a common tangent. But first, let me write the one for direct common tangent. So for direct common tangent, you already know what that is now. L, this L is the length of the tangent, is equal to d squared minus r, this for direct, minus r squared or square root. This for direct common tangent. This L here is the length, or don't worry, I'll still write it, is the length of the tangent, and this d is the distance between the centers of the two circles. Big arrow is the radius of the bigger circle, small arrow is the radius of the smaller circle. So this is for direct common tangent. But what about for transverse common tangent? The formula is just almost the same thing, just a difference here. It is L is equal to d squared minus big arrow plus small r all squared. Then you have the square root like this. So this is the formula for calculating the length of a transverse common tangent. See, let me just help you out. For direct, direct, minus here and minus here for direct. But for transverse, where you have it in this form, okay? For transverse, there's minus here as you have minus here, but this one is not minus, it's plus. So the only difference between direct and the transverse is that for direct, you have minus and minus, but for transverse, you have plus here. So don't mix up the two formulas, okay? Now, L is the length of the tangent, then D is the distance between the two centers of the circles. All right, so L is the length of the tangent. This L, if they ask you to find the length of the tangent, and the tangent is a transverse tangent, use this formula. There are other ways you can do this, but I just want to let you know the formula first. If it is direct common tangent, use this formula. Hope that makes sense. So you know what big arrow and small arrow is? Big arrow is the radius of the bigger circle, while small arrow is the radius of the smaller circle. Have any question, ask as we move on. If you have any question, ask as we move on. Where do I live? Well, for now, I'm in Nigeria. I am in Nigeria, okay? All right, so I think if you have any question, ask. I'll take a screenshot. You will need these two formulas, okay? They are very, very important. So take a screenshot of what we have on the board as we start solving some very interesting questions. Take a screenshot if you have not done so. Please, let's like the live. Let's like the live. Can I move on? If you want me to move on, type 1 in the comment. If you want me to move on, type 1 in the comments. If you want me to move on, type 1 in the comments. Thank you, Lamar. Thank you, Lamar. I hope this is making sense to every one of you. Yeah, thank you, Lamar. We need to move on. So the two formulas are here now. For this, for transverse, this formula. You see, this formula is very easy to use. The other method, you would need to do some other work behind it. But with this formula, directly you plug it into the formula and you get your answer straight up. So please, if you have not taken a screenshot, I don't know why you haven't, but I said you should. Okay, I need to take off most of these things so we have space at the top, okay? You already know what we're talking about, direct and transverse common tangents. Yeah. If you are gaining something from this lesson, let me see you type 1 in the comments. So we have some examples here. Okay, so examples. Number 1. Well, I'll just try to write this down. In the figure below, the line segment ST is tangent to the two circles, S and T. O and Q are the centers of the circles with OS equal to 5 centimeters, QT 2 centimeters, QT is 2 centimeters, and OQ is 14 centimeters. Find ST. Sir, can I help me? Can I help you in math? Yeah, sure, I can. That's exactly what I'm doing. That's why I'm having this lesson. But if you want my premium lessons, you can reach out to me on my bio. There's a link on my bio that can take you to my DM on WhatsApp. Yeah. If you want more, and like I said before, I'm having a premium class starting in November. So if you want to join, sure, you are all welcome. Okay, without wasting time, let me just join this too. Yeah. So I have this. Okay. S. Yeah, this is S. This is O. 5 centimeters. Okay, I think we have this. Yeah. What else? Okay, I think that's all. Okay, yeah, that's fine. So see, they say find ST. All of this information I've just written, they are all contained in this diagram. So we have two circles. This is bigger circle. Obviously, the radius is 5 centimeters. This is the smaller circle. The radius obviously is what? 2 centimeters. And we're asked to find ST. Where is that? ST. Where is ST? See, from S here to T. ST is a tangent. If you agree, type yes in the comment. ST, now, somebody should tell me, is ST a direct common tangent or a transverse common tangent? If you know it, type in the comment. Don't see it, just do it by your own. If you understand what I just said now, can you type it in the comment? Is ST a direct common tangent or a transverse common tangent? Type it in the comment. You know, in my class, I like interaction. You must participate. I need to know that you're with me. Okay? So, what is the difference? Oh. What is the difference? It seems you are just coming on. Whatever. It seems you're just coming. For those of you that have been here, please prove me that I have done something today. Tell me, what type of tangent is this one? Is it transverse or direct? Lama, yes to what? I need you to tell me what type of tangent is this. Somebody should bail everyone. Somebody should prove to me that you have been in this lesson and you have been participating in everything I've been saying. What type of tangent is this? ST, what type of tangent? Is it transverse or direct? Somebody should talk to me. 45 of you, there has to be somebody who knows what tangent this is. I'm waiting. So are you preparing for what? Direct. Oh, it's not direct. Oh, it's not direct. You know, I told you that for direct, it will go from the top to the top or the base to the base of the two circles. They will just be in the same position. But this is going this way now. See, it's going from top here to the base. So that this is transverse. All right. That's transverse. Yes, thank you. Thank you, Moses. It's transverse, okay? It's transverse. So give me 1 minute. I need to plug in my lighting system. 1 minute, please. Okay, can we continue? Sorry about that. I had to plug in my lighting system. So please, it is transverse. Let me quickly explain again for those of you that are just joining us. See, if you have two circles like this, right? If the tangent is going from here to here, this is direct tangent, direct common tangent. Okay? But if it is going, if you have something like this, see from here to here, this is tangent, this is transverse. This is direct common tangent. See from top to the top here, all right? Why this is transverse? This is transverse common tangent. Is that okay? So please, let's not, because if you cannot identify the type of tangent, you're not able to use that formula that I gave you before. One is for direct, the other is for transverse. So you need to know how to identify the tangent. It's very, very important. Okay. So like I told you, I said I was going to show you different ways you can actually do this. And I'm going to keep to my word. So since we know that this is a transverse common tangent, the formula is what again? I hope you still remember the formula. So ST is a transverse common tangent. And if you ask to find ST, that's the length of the tangent, which you use L to denote it. So L is the length of the tangent, will be equal to, I said what? D squared. D squared is the distance between the centers of the two circles. So from O to Q minus R plus. Now, you know I told you for transverse, it is plus. So plus this, and then you have the square root. This is the formula you're going to use to calculate the length of the transverse tangent. I hope you are with me. Yeah, the length of the transverse common tangent is given by this formula. Like I said, there are other ways you can do this. So L will be equal to, D here is from O to Q. And what's that? We're told in the question, OQ is what? 14 centimeters from O, the center of the bigger circle, to Q, which is the center of the smaller circle. So from O to Q is what? 14, which means D will be 14. But it is 14 squared because of the formula D squared, then minus what? Big R is 5, as you can see here, 5 plus small r is what? 2. You square it, you wrap everything in this radical symbol. Hope that makes sense. All right, so L will be equal to 14 squared is 196, right? 196 minus, what about 5 plus 2? That's 7. And when you square that number, you get what? You get 49. Hope you are all with me. Thank you, David. Thank you, Wenzi. Thank you, all of you. Thank you so much for the height. So what is 196 minus 49? All right. You take one from it. This is 8. 16 minus 9 is what? Isn't that 7? This is 4. So that's 147. So the square root of 147. All right. But we can simplify this further. If we want to leave an answer in short form, we know how we can do that, right? We want to leave an answer in short form, we know what we can do. So I think a 3 can divide 147. 1 plus 4 is 5. 5 plus 7 is 12. So that is what? If you divide 147 by 3, this is 4. So that's 49. So it means that this can be expressed as what? Square root of 49 times square root of 3. I want to leave my answer in short form. So L here will be equal to, what is square root of 49? That's 7. So 7 root 3 centimeters. So the length of this tangent is 7 root 3 centimeters. Hope that makes sense. If you understood what I've done so far, please type yes in the comments. Or just type 1. If this is clear to you, type 1 in the comments. Type 1 in the comments. If you understood what I've done so far, type 1 in the comments. Thank you, Lama. Thank you, Lily says, thank you. So that's it. That's how you solve questions like this. Please don't forget this formula. The length of the tangent is given by this formula. For transverse, yes, plus. For direct, this plus is minus. That's the only difference between transverse common tangent and direct common tangent. So how about I show you another way? Although this method I want to use now is, this formula was gotten from this other method, but I want to explain this formula to you so that even if you cannot remember this formula, you can reconstruct this in a way that without this formula, you should be able to still get your answer. Because some people might not remember this formula, and it's very, very normal. All right. If you want to do this without using this formula, though an application of this formula will be used, but let's do it another way. So this is 7 root 3, by the way. So I'm going to do this without using the formula. Okay? Let's do this together. So look at this. This is 2. By the way, do you know that this angle here, this is 90 degrees? The angle between a radius and a tangent is 90 degrees. Okay? Same here too. This is also what? 90 degrees, because this is a tangent and then a radius. So we have a right angle here, we have another right angle here. How about we do something? How about we extend? See, if I want to construct this now, because I'm trying to get ST, all right, I can do a construction like this. Watch this now. See, I'm going to draw a line that will be parallel to ST. As you can see, I will draw another line. So let's call this one, let's call this M. So what I've just done is that I just said now that QM is what? Parallel to ST. It's parallel to ST. Here. So if I join this now, what I have what is a right angle, is a rectangle, because this is 90 degrees. And because this line QM is parallel to TS, this is also what? 90 degrees. So what we have here is what? A rectangle. And you know what rectangles are? The opposite sides are equal, all right? And all the angles are 90 degrees. So it means that MQ will be equal to what? ST. So MQ, wait, before that, I'm going to say that what? That SMQT is a rectangle. All right, is a rectangle. So if that's a rectangle, it also means that what? MQ is equal to what? ST. And why is this so? Opposite angles, opposite sides of a rectangle. Okay, very good. So all we have to do, if I can get MQ, I can just say whatever MQ is will be the same thing as what? ST. Let me say it again. Whatever MQ is will be the same thing as what? ST, because they are opposite sides of a rectangle. Hope that's making sense now. Beautiful. So let's continue. Let's continue. So how do I get MQ? That's very easy. I can say that OMQ is a right angle triangle. Let me say it again. OMQ is a right angled triangle. All right? So if it's a right angle triangle, of course, we know the Pythagoras theorem of a right angle triangle. If you don't know, the square of the longest side is equal to the sum of the squares of the other two sides. So what we have here is a right angle, right? And that means that this side facing it, OQ, is a hypotenuse. So using Pythagoras theorem, Pythagoras theorem, what am I trying to get? Wait, before that, see, because TQ is 2 centimeters, and I drew QM to be parallel to ST, so it means that From S to M, SM will also be what? 2 centimeters. So let me write here that what? That SM is, or I'll use another color so that you see what I'm writing clearly. So SM is equal to what? QT. And they are both equal to 2 centimeters. So this is 2 centimeters. You see that now? What am I trying to work with? I'm trying to work with what? OMQ is a right angle triangle. Where is that? From O to M to Q. You see that? From O to M to Q is a right angle triangle. And that's what we are working with. See what I'm working with now. See. I'm working with this triangle. OQM or OMQ. That's a right angle triangle. So the longest side here is what? OQ, because it's facing the right angle. If you trace it down, this is OQ. So OQ is what? OQ from the question is what? 14 centimeters. All right. And from Pythagoras theorem, the square of the longest side. The square of the longest side. What's the longest side? OQ. So I'll say that 14 squared is equal to what? OM. What's OMC? From O to M is what? 7 centimeters. From O all the way to M, because 5 plus 2 is what? 7. So that would be 7 squared plus what now? MQ. So MQ squared. So when you take this over to the left-hand side, they are going to have 14 squared minus 7 squared is equal to MQ squared. All right. I want to complete. So what is, the other time that we did this, we got 14 squared as what? 196. I'll continue from here now. So 196 minus what? 49 is equal to MQ squared. But when you square root both sides, you have your square root here. All right? You have it there. So 196 minus 49, what did you get it as the last time? I want you to participate, please. Let's participate. What's 196 minus 149? Minus 49 rather. What's that? The last time we got what? 147. And we were able to write 49 times 3. If you multiply 49 and 3, you get 147. So this is what? 7 root 3. Like we did earlier. Now, you remember that MQ is equal to ST. So here, MQ is equal to ST. Therefore, ST will be equal to what? Same thing as MQ. 7 root 3 centimeters. So can you see how I was able to do this without using that formula? And in case you don't remember the formula, you can always just do your small construction on the tangent and on the line connecting both centers of the circle. And then be able to use Pythagoras theorem for the right angle triangle, which will now give you your answer. Hope this makes sense. Thank you, whatever. Thank you. Understand this, sir. Thank you for the feedback. I'm so happy for your feedback. So I hope you now understand how to get the length of a common tangent between two circles, okay? Yeah, this is basically how it is done. Just know that somewhere you get a right angle triangle, because we're dealing with a tangent. We're also dealing with a radius. Wherever a tangent meets a radius, you get 90 degrees, okay? Yeah, so that's it. That's it. I don't know if you have any question before we move on. This is how I want us to do another question that will involve direct common tangent. This one is transverse, but let's do another one that will involve direct common tangent. If this is clear to you, type yes in the comment. If you want me to take off the board, please, sorry about the lighting. It's not really great. I'm working on getting a better lighting, of course, okay? And for those of you who may be wondering, oh, with the premium class be like this? No. I'm getting all those gadgets and tools very soon. The premium class is not going to be like this. And of course, very soon too, we'll get another light that would also improve the quality of the lighting you see here now. So once again, I apologize for the poor lighting. We are working on getting another light. So quickly, if you have not joined my community, please do so. It's on my WhatsApp. I have a Max community on WhatsApp and also on Telegram. So whatever works for you, go to my bio. Just go to my bio. You will see, excuse me, you are going to see a link where you can join my WhatsApp community or my Telegram channel. Any of them that you want to join. Even if you want to join the two. Also, I have a WhatsApp channel. Anyone you want to join is fine. The reason why you have to join is because whenever I have update, like now, I was supposed to have a class yesterday, but I could not because I was very tired. I was on the road for some hours, so I came back tired. So I had to tell those in my community that I wouldn't be having a class yesterday, but today. So this is the importance of joining my community. If you have not joined my community, try to join. So that whenever there's any update, you'll be the first to know. Okay? Don't worry, nobody is going to spam you. Nobody is going to send you any message in the community. It's safe and everybody is well behaved in the community. So if you want me to move on, kindly type yes in the comments. I had to clean the board. Type yes in the comments. What is chord, sir? I am beginner. Chord. What subject is this? These circle theorems. Circle theorems. Chord. Chord is a line segment joining two parts of a circle. See, you have a circle like this. Sorry, it's not a perfect circle. You have the center. If you have a line joining two parts of the circle, that's a chord. From here to here, this is a chord. AB is a chord. CD is a chord. It doesn't have to pass through the center of the circle. If it passes through the center, it becomes it's a chord that is a diameter because it passes through the center. But if it does not, it's just a chord and not a diameter. So that's what a chord is. You need to see, if this is your first time of joining this lesson, yeah, this is the 7th class we're having on circle theorems. We've done 1, 2, 3, 4, 5, 6. This is the 7th lesson. Go to my live playlist. You see all the videos there. So start from the first one to the second, third, and like that. So you might not be able to understand what we're doing if this is your first time. This is 7th lesson, and I think it should be the last one for this topic. And again, I also need you to put your topic suggestion in the comment. If you want me to treat it, though I have something in mind, but maybe you have a special request for any topic, put it in the comments. I will get to see it and get back to you. So we have another question. This is going to be very interesting. So example 2, what do we have? Yeah, the distance between the centers of two circles is 10 centimeters. The radii of the centers are 3 centimeters and 5 centimeters. Find the length of a direct common tangent to both circles. B, transverse common tangent to both circles. Beautiful question. So no diagram was given. We just have this question here. Okay. They said the distance between the two centers, so they give us the distance. Now, one of the circle has a radius of 3, the other has a radius of 5. So clearly one is bigger than the other. So let me just write solution here and then draw the two circles, one here and the other here. Yeah, okay. Like I said, it's not drawn to scale at all. We're given the, so this, now look at this direct common and transverse common tangent. So we're dealing with two things here. Let's start with the direct common tangent. That's the first one. So for direct, I will have something drawn from here to here. From here to here. This is direct, okay? Good. I'm getting better with these drawings. So, yeah, let's call this O, center O. Let's call this C. And what I have here is a radius, another radius, okay? Very good. We're told that one of the radius is what? One of the radii is 3 centimeters. So this is 3. Why this is what? 5. I hope you are with me. Very good. Now, that's not all. They gave us the distance between the centers of the two circles. So from here to here. This is the distance between the two circles. Hope you can see it. Yes, yes. And the distance is what? 10 centimeters. Okay. Now, you know what? I want us to start first using that formula that I gave you before. What's that formula again? Hope you still remember the formula. Our interesting formula. We're asked to find the direct common tangent. Tangent. For direct common tangent, I give you that interesting formula as what? L, which is the length of the tangent, is equal to what? D squared minus big R. See, this is direct now, right? Okay, I think we should label this OC. Let's call this AB. AB, okay? Let's call it AB. So we are looking for what? Length AB. So the formula is what? R plus small r, all squared, and then your square root. Very, very straightforward and easy. So the length of this is going to be what? The square root of what? D is the distance between the centers, given as what? 10 centimeters. So this is going to be 10 squared, then minus. Big R is 5, so 5, small r is 3, okay? All squared. So this is what? 10 squared is 100 minus 8. 5 plus 3 is 8, okay? What is chord? So, okay, sorry. Then what is the difference between diameter and chord? Oh, very interesting question. So 5 plus 3 is 8. 8 squared is what? 64. And what would this be? 100 minus 64 is what? Is that not 36? And what is the square root of 36? That's 6. So the length of the tangent is what? 6 centimeters. All right, the length of the tangent is 6 centimeters. You see how easy and straightforward this is using the formula. But what about if you cannot remember the formula? What about if you cannot remember the formula and you still want to do this without using the formula? Although, like I said, what we are still going to do is like a derivation. All right. The formula is a derivation from what we are going to do. What are we looking for again? We are looking for what? A, B. But I need you to know that this angle here is what? 90 degrees. By now you should know that the angle between a tangent and a radius. This is also what? 90 degrees. Between a radius and what? A tangent. Okay? Lovely. So, like I did before, we are going to construct a line that will be parallel to AB. Let me say that again. We are going to construct a line that will be parallel to what? AB. AB is what we are asked to find. So, but we might not be able to get AB directly until we construct another line that will not help us form a right angle triangle. So watch this now. I'm going to construct a line that will parallel to AB like this. So this is 90, this will be 90 as well. So we can call this, let's call this ABCD. We do have D, no, let's call this D. So I'm going to say that what? Okay, I need to clean this off now. I'm showing you another method. Okay, so we can say that what? What here? Okay, what are we doing here? So back to what we're talking about, we can say that what? Hold on a second. This is 90 degrees. All right. We can say that OD is parallel to AB, to line AB. And what we have now is a right angle triangle. So I will say that ODC is a right angled triangle. Okay? Yeah. Now let me bring out this. What am I trying to find? If I can get OD, I can get AB because OABD is a rectangle. As you can see, OABD is a rectangle, right? OABD is a rectangle. So it therefore means that when I bring out this triangle, I'll have something like this. All right. I'm trying to redraw this now. This is O, this is D, and this is what? C. What am I trying to get? OD. If I can get OD, it will be equal to what? AB. So I'm going to write here that what? That OD is equal to AB. And why is that so? Opposite sides of a rectangle. Beautiful. This is 90 degrees. It's from here, 90. We already know what OC is. OC was given as what? 10. That's the distance between the two centers. OC is what? 10. So this is 10 already. Okay? Yeah, this is 10. But what about DC? How can we get DC? Who can tell us? How can we get DC? Thank you, Abdullah. Who can tell us how can we get DC? Let's look at where C is. This is D here. We know that BC is 5. And we know that AO is 3. But how can we get from D to C? Because if we don't get this side, we cannot get OD. Thank you. Oh my God. Thank you, Mana. Thank you so much for your comment. I'm so grateful. Thank you so much. Who can tell us how can we get CD? We need to get CD. Anybody helping us with that? Anybody? Now let me tell you something. Do you know that OA and BD are equal because they're the opposite sides of a rectangle? So if AO is equal to BD and they're both equal to 3, it means that if this is 3, then this has to be 2. Because when you add 3 to 2, you get 5. Remember, from B to C is 5. So for me to get DC, I'm going to say that DC is equal to 5 minus 3, which is 2. So this is what? 2. This is 2. Hope that's okay. Yeah. Thank you so much. Oh, thank you, Calvin. Thank you. Thank you, Okeleye. So this is a rectangle, right? This is a rectangle. Now, this is 2. This is the hypotenuse, the longest side of the right angle triangle is facing the right angle. What about OD now? So to get OD, I'm going to say that OD squared will be equal to the square of the longest side minus the other side. That would be 10 squared. But we are using Pythagoras theorem, actually. So I'm going to say Pythagoras theorem for those of you who might not understand what we're doing. The square of the longest side, 10 squared, is equal to the sum of squares of the other two sides. OD, let me just write OD squared, okay? So this is 100. Let's move 2 squared over. You have this is equal to OD squared. So what's 100 minus 4? That's 96, right? I hope I'm on the right track. Thank you. Yeah, thank you. So let's wrap it up here now. The square root of 96 is what? I don't know how we left the other answer. Did we even write the other answer in this form? So this won't be anymore. OD will be equal to 9 how will we actually leave our answer? 2 significant figures. So that's 9.80. Is there any mistake somewhere? Someone should help me out. Any mistake? But I don't think so. We're trying to get what? We're trying to get OD. Any mistake anywhere? I don't think so. So the square root of 96 is what? That OD is equal to AB. And what we're trying to find is actually AB. AB is the tangent. So if you already got what OD is as 9.8, therefore AB will also be equal to what? 9.8 centimeters. And that will bring us to the conclusion that the length of the common tangent is 9.8 centimeters. That's it. Thank you, Okeleye Ayomide. Thank you. So the length of the common tangent AB is going to be what? 9.8 centimeters. And that's it. So this is 9.8 centimeters, correct to 2 significant figures. All right, we've done how to do it using the, okay, we've not even used the, have we used the formula? I don't think so. What about the formula? Oh, thank you, that led to the 6 before. That led to 6 before. Which 6? That led to 6. Okay, that led to 6. Hold on. That led to 6. What happened to that formula? I think I know what happened. We used the, oh my goodness, we used the transverse. Oh, I know nobody even brought my mind to it. Thank you, Akamu. What we did before was for transverse. This is direct. There's an issue with that one. My goodness. What have I done? What have I done? So I have to clean this up and rework it again. Oh my goodness. We have to rework it again. So this is 9.6. Okay. So that formula, we wrongly applied it. The formula quickly is what? Is d squared minus r minus, because it's direct. Thank you for pointing that out. Thank you, Akamu. Yes, thank you, Akamu, for that. So it's going to be d is the distance between the centers, given as what? 10. So 10 squared minus big R is what? 5 minus small r is what? 3. All squared. That was a mistake. Sorry about that. So this is 100 minus 5 minus 3 is 2. And 2 squared is 4. Okay? And you saw something was off. So you see now, you see how confusing this can be. That's why if this formula is not going to help you, please just use this other method. This one is almost fail-proof. You are likely not going to get any error. But a single change of minus to plus will mess up the whole thing. So again, you see the answer now, the square root of 96, we got what? 9.8, right? Now the answer we're going for, 9.8 centimeters. So sorry, that one we did before was for transverse common tangent and not for direct. So this is the correct one for the direct. This is the formula now We use plus for the other one, but it's supposed to be minus for direct. Transverse is minus and plus. Direct is minus and minus. Yeah, thank you. Thank you, Okeleye. Yes, thank you, Fresta. Okay, now the beautiful thing about using the formula method is very straightforward. We don't have to do any construction. We don't have to do any manipulation. Quickly, we just plug it into the formula and we got the answer in few steps. So that's it. Now, I will allow you to do the other one. Excuse me. I'm going to allow you to do the other one. Transverse common tangent to both circles. Let me give you the chance to do the second one, even though we have done it. But for those of you who want to try, I'm going to give you the chance to use the other method. Okay? So I have to clean this. Yeah. So we're doing the second one now. Okay, anybody? Please, can you draw the transverse common tangent? Oh, thank you. Yes, I'm going to draw it now. Let me just take off all of this. As a matter of fact, everything has to go again. So for the transverse, again, we have a smaller circle here and the bigger circle here, okay? For transverse, it's going to be from top here to the base. Oh, sorry. You're going to go like this. Yeah. Okay, good. So this is the transverse, as you can see, from here to the other side, okay? This is the center. I think we call this O, we call this C, but it doesn't matter, even if, since we are redrawing it. All right, now this is the radius. This is the radius, okay? And this is the distance between the two. Yeah. So here you go. Let's call this A and B. This is A, this is B. Okay. So who's going to help us with the, who's going to help us to do this? Transverse common tangent. We want to get the length of the transverse common tangent to both circles. Yeah. The formula again is what? D squared minus, this is transverse. So big R plus, that's for transverse. All squared with the square root here like this. Transverse minus plus. So you can use this to even recall it. Transverse, opposite, minus plus. Direct, same, minus minus. Hope that makes sense. Transverse, opposite, minus plus. Direct, minus minus. With this, you should not forget. So the length is what? D is what? The distance between the two centers. That's 10. So 10 squared minus. Big R is what? 5. Sorry, 5 and 3, right? So this is 5, this is 3. So 5 plus 3, all squared. And that's 100 minus what? 64. Which is what? What's 100 minus 64? That's 36. What is squared that you get 6? So the length of the transverse common tangent is 6 centimeters. If you want me to use the other method, type 1 in the comment. If you want me to use the other method to explain this, type 1 in the comment. But if not, just type 2. If you want us to move on, type 2. Excuse me. If you want me to use the other method, type 1 in the comment. I'll be checking the comment. Thank you, Branca. Please, let's like the live. Please, I need your support. Let's like the live. Thank you so much. Please let's like the live so more people can join us. Okay, let's like the live. Do you want me to move on, or we should or I should use the other method? Mhm. The one with rectangle is second method, right? Yes. Thank you. Yes, yes, it is. The one where I had to construct a rectangle is the second method. So if now I might not finish this, maybe I should not finish this. What you can do, right, is this is the tangent. So you are basically constructing a line that will be parallel to the tangent. All right. If AB is the tangent, you can actually construct another line. So that means that we have a rectangle. I can extend this. Okay. So this is 5. If this is 5, I think this one can be drawn better. Yeah. So if this is 5, when you take it down, this will be 5 as well. All right. And it means that, let's call this M. It means that OMC is what? A right angle triangle. But because this one will also be what? Remember, this is 90 degrees. This is 90. So if you are constructing another line, this is 90. This should be 90 as well. So we have a right angle triangle. Triangle OMC. OMC is a right angle triangle. Okay, say, Claire, you did that already. Yes, I did that already. Yes, I already did that already. So OMC is a right angled triangle, right? Okay. Let me just bring out like this. It can be drawn better. Yeah. So if this is the right angle triangle, this is from here to here is what? For OM is 8, right? Because this is 3, this is 5. When you add, you get 8. And if AB, what's AB? No, we don't know what AB is, but we know what OC is. OC is 10. So this is 10. All right. We are trying to get MC. MC is parallel to what? AB, and they're equal because they form a rectangle. Okay. What if the radii is 5 and 5? How would, if it is 5 and 5, yeah, which means you have two similar circles, right? Yeah, so it's still going to be the same thing, the same approach. So nothing is going to change. Now MC is not the longest side. This is the longest side. So to get MC, that would be what? Sorry, that would be 10 squared minus what? 8 squared with the square root like this. And that's what? 100 minus 64, right? This is what? 36, which is 6. So if MC is 6, it means that what? AB will be 6 as well because they are opposite sides of a rectangle. So the tangent AB is what? 6. So MC is equal to AB, which is equal to 6 centimeters. So that's how you also use the other method. In case you don't want to, as a matter of fact, that formula method was derived from this. If you don't want to do your other construction as I've just done, you can easily use the formula method and get your answers straight up. Okay, people, I want to appreciate all of you. But before I end this lesson, I want us to solve 1 or 2 questions, but it's not going to be based off of what we have done so far. It's not going to be based off of direct or transverse common tangent. I just picked about 2 or 3 random questions. If we do 1 or 2 and we have to go, then I will just call it equal. So we have covered all the aspects of circle theorems, all the aspects. I want to believe so. The last lesson we talked about intersecting circles. I mean, intersecting chord and secant, and there's a theorem for that. If you miss that lesson, it's the previous class before this one. It's important you also go back and watch that video, okay? And we've talked about the opposite circles of a cyclic quadrilateral, the angle at the center theorem, the angle in a semicircle, angle between a tangent and a chord, angle in the alternate segment theorem. Quite a lot of theorems that we have looked at, okay? Even the chord properties as well. So I think we should just do a quick refresher of what we have done. Giving you one or two questions, and that'll be all for today's lesson. I didn't see your suggestions in the comment section. What should be the next topic after this? I didn't see your suggestion in the comments. Or I should just do what I want to do. I should just bring a new topic that I feel is going to be okay. If you have any topic suggestion, put it in the comments. I'm looking at the comments. So, yes. Awesome. Where are we? Okay, number 11. I saw a question here. Okay. This is a circle. This is in the center. Okay, so what we're asked to find is, now TA is the tangent. I'm not going to write that. So we want to find P and Q. And second, we want to also find TA. So those are the two questions we want to find here. I don't know, in case you know what we can do here, you might want to. Oh, sorry, what? Let me adjust this. Okay, hope it's better now. Let me adjust it. All right. So we want to get P and Q, we want to get TA, but let's start with getting P and Q. Who wants to help us? How can we get P and Q? The camera lens sometimes can't focus. Yes. I just readjusted it again. Okay. Who wants to help us? How can we get P and Q? Excuse me. So I hope you know that the angle between a radius and a tangent at the point of contact is 90 degrees. So now they didn't tell us, of course, they expect you to know. So this is 90 degrees. All right, yeah, that's 90 degrees. So if that is the case, that will help us. You might say TA triangle TAO is right angled. And we know that when you add all the angles in a triangle, it will be what? 90 degrees, sorry, 180 degrees. So when you add P to 4P to 90 degrees, you will get 180 degrees. If you add all the angles in a triangle, in bracket, I will say sum of angles in a triangle, sum of angles in a triangle, okay? P plus 4P is 5P. Move 90 over, you get what? Minus 90 degrees. So 5P is equal to 180 minus 90 is what? 90 degrees. Divide both sides by 5. What are you going to have? Hello, yeah, thank you, channel. What's that? So divide both sides by 5. P will be equal to 90 degrees over 5, and that's what? 18 degrees. We've gotten P. How can we get Q? Now that we have P, that should not be a problem, right? How can we get Q? Who wants to help us with that? Let me give you 1 or 2 minutes to try. But before that, I want to give you a clue. Do you know that OB from O to B is equal to OA? In brackets, same radii. All right? Many people don't know this. If you have a triangle in a circle, and that triangle is bounded by 2 radii, that triangle is isosceles. You will not be told. You will not be told at all. So this OB and OA, they are equal. They are isosceles. Since both sides are equal, that makes an isosceles triangle, right? Yeah. So you may ask, how is that going to help us? Of course, it will, because we know that this angle here, angle OAB, will also be Q. Why is that so? Base angles of an isosceles triangle. Okay? Yeah. And I'm going to say that OBA, triangle OBA or OAB is isosceles. So if it is isosceles, what does that mean? It means that what? That the base angles are equal. So Q plus 4P. 4P is the third angle in the triangle, plus 4P, all will add up to 180 degrees. We already know what P is. P is 18. So Q plus Q is 2Q plus 4P. That's 4 times 18 degrees. What's 4 times 18? That should be easy, right? 4 times 8 is 32. 4 times 1 is 4 plus 7 is 3. So that's 72 degrees. If you move 72 over, trigonometry next. Okay, trigonometry, I think that was what I even thought about first, and I think we're going to do that. 180 minus 72 is 108 degrees. The Bible says by 2, Q is equal to 108 degrees over 2, and that's what? 54 degrees. So yes, we've gotten Q as 54 degrees. Okay, Q is 54 degrees. I think this is going to be the last example we do. Now we have P, we have Q. Let's find TA. So where is TA? TA is not an angle, it's the side. Okay? We're still going to use one of those trig ratios. Remember, when you have a right angle triangle, sine, cosine, and what? And tangent. I think we are through. Please take a screenshot if you want to do that. I've already gotten Q, and we have P already. Take a screenshot. So we're going to wrap up with this. Okay. So let me take this off, okay? Oh, let me not forget. What did you get as Q again? Q is what? Q is 54, right? And what's P? P is 18. Right? P is 18. Is that not? Okay. Okay, good. So let me bring out this triangle out so you see what I'm doing clearly. This is AOT. Okay? We need to get TA from the question. Find TA. P is what? 18 degrees. P, 18 degrees, okay? And then 4P. What was 4P again? Is it not 70? Even though we don't need this, we can use any of the angles. This is 5 centimeters, okay? How do we now get TA? If I want to use this angle, if I want to use 18 degrees, this is going to be the what? Opposite. Opposite. This is the hypotenuse, the side facing the right angle, while this other side is what? Adjacent. So we are looking for the adjacent of the right angle triangle. Hope that makes sense. So what connects adjacent and opposite? Adjacent and opposite. Is that not tan? from SOHCAHTOA. That's the mnemonics for this, SOHCAHTOA. So we're using this opposite and adjacent, tan. So tan 18 degrees will be equal to the opposite, which is 5 over the what? Tan 18 degrees, opposite over the adjacent, which is TA. When you cross multiply, what's that going to be? So TA times tan 18 degrees. I can actually just skip this step. So let's divide both sides by tan 18 degrees. Thank you, Nikewe. Hope I got that right. So 5 over tan 18 degrees, okay? What's tan 18 degrees? Let's get our calculator and do that. Tan 18 is 0.3249, 0.3249. So TA will be equal to 5 divided by 0.3249. So 5 divided by 0.3249, which is 15.3894. 15.32, 3894 rather, 3894. Now they said to what? I think it was, okay, I didn't write it, but they said to what? Okay, even if it is not stated, let's leave answer to one decimal place. That's 15.4 centimeters. Okay, so this is the length of TA, 15.4 centimeters. Thank you, Nikewe. Yeah, thank you for all of you for staying through to this time. I hope you enjoyed this lesson. If you did, kindly share this video or just let people know about this lesson that we've had and other lessons we've had. Like I said, this is the 7th lesson we're having on circle theorems. And subscribe to this channel if you have not done so already, so that when I upload my videos on my long channel or my short videos, you'll be able to see them and also support me by watching, liking, sharing the video with your friends and family. And again, I'm also thinking I will move on to trigonometry. That is likely going to be the next topic. Okay. I also want to crave your indulgence. If you have not community, head on to my bio. You'll see my Telegram channel, my WhatsApp channel, any of them, or I have 3 communities: WhatsApp channel, WhatsApp group, Telegram channel. Any of them you want to join, you can always check them out on my channel. My paid class is starting in November. It will run from November till April next year for 6 months, and it's just very affordable. $37 for the class for the period of 6 months. So make sure you also, if you check my bio, there will be a link for you to send me a message asking to join my paid class. And if you pay now, if you register now, you are going to do so with a heavy discount. But when the class starts, the price will be far more than what it is now. So you want to take advantage of the discount, heavy discount that's running for the paid classes. That said, I don't know if you have any question. Let me know in the comments if you have any question. Thank you. Yeah, thank you. Waiting for trigonometry. Yes. My next class, I may have another class tomorrow. Tomorrow is Sunday, right? Okay, we may have another class tomorrow by 9 p.m. West Africa time. Yeah, very possible. I could have another class. So if you want to be aware, all right, you want to be the first to know, head on to my bio and join my free class on WhatsApp and Telegram. That said, if there's no question, I think I'll have to call it a close now, unless you have any question for me. But if not, I think I have to go. Any question? If you don't have any question, ask. If you have any question, ask. And if you have not liked this live, do so. We're almost ended the live. Like the live, so the like count will also increase. Okay. Yeah, we've come to the end of this topic: circle theorems, circle geometry. Our next lesson is going to be trigonometry. I want to believe so, unless there's a change. But I think the next lesson will be on trigonometry. Thank you, every one of you, for your support, for staying to the end of this lesson. Hope to see you tomorrow by 9 p.m. West Africa time. Bye-bye.